Hello and welcome to the channel, where today we're diving into one of the most fascinating stories in ancient DNA research, the remarkable rewrite of the life story of Beachy Head Woman, once celebrated as Britain's first known black resident from Roman times. Imagine this. Eastbourne, Southern England, 2012. Archaeologists are cataloging old remains in a town hall collection when they stumble upon a skeleton buried on a windswept cliff overlooking the English Channel. Radiocarbon dating places her death between 129 and 311 AD, deep in the Roman era. Her skull measurements suggest sub-Saharan African ancestry. Headlines explode. First Black Briton discovered. She becomes an icon. Proof of diversity in Roman Britain, a powerful symbol for modern conversations about race, migration, and belonging. Textbooks mention her. Documentaries feature her. Beachy Head Woman, as she's dubbed, is hailed as evidence that black people have been part of Britain's story for nearly 2,000 years. Fast forward to 2025, and cutting-edge ancient DNA technology has just flipped the entire narrative upside down. A new study published in the Journal of Archaeological Science used high-quality genome sequencing, a massive leap from the low-coverage DNA tested in 2017 and the skull measurements from 2013. To reveal the truth, Beachy Head Woman wasn't from sub-Saharan Africa. She wasn't even from the Mediterranean, as some later suggested. She was born and raised right there in southern England, with genetic ancestry matching local Roman-era Britons. Fair skin, light hair, blue eyes. A young woman, 18 to 25, just under 5 feet tall, who ate plenty of seafood and survived a serious leg injury before her death. The researchers combined this DNA data with a 3D scan of her skull to create a stunning facial reconstruction. A fair-haired, blue-eyed young woman gazing out over the same cliffs where she was buried. It's a breathtaking image that humanizes her in a whole new way. Co-author William Marsh from London's Natural History Museum summed it up perfectly. Our scientific knowledge is constantly evolving, and as scientists, it's our job to keep pushing for answers. Senior researcher Selena Brace added, "Thanks to advancements in the past decade, we're excited to share more about this individual and her life. This isn't a scandal or a cover-up. It's science doing exactly what it's supposed to do, self-correcting." In 2013, craniometric analysis, measuring skull features, was the best tool available, and it pointed to sub-Saharan origins. In 2017, early DNA hinted at Mediterranean roots. Now, with state-of-the-art sequencing, we have the clearest picture yet. She was local. Bioarchaeologist Thomas Booth called it an excellent transparent example of science self-correcting, while noting that craniometric methods, long controversial for their roots in racial pseudoscience, might need a serious reckoning. The story of Beachy Head Woman reminds us how quickly our understanding of the past can change with better tools. Roman Britain was undeniably diverse. Traders, soldiers, and families from across the empire left traces from North Africa to Syria. But this particular individual, whose remains captured the public imagination, turns out to be a native Briton. Her life, the seafood diet, the healed wound, the cliffside burial, paints a vivid picture of everyday existence in Roman England. So what does this mean for the bigger conversation about diversity in ancient Britain? Nothing is erased. The empire brought people from everywhere. Genetic studies of Roman-era burials still show North African, Middle Eastern, and European ancestry mixing in places like York and London. But Beachy Head Woman's updated story is a powerful reminder. Assume nothing, test everything, and let the evidence lead. Science isn't about being right the first time. It's about getting closer to the truth with every new discovery. Drop a DNA helix emoji if you love stories like this, a skull if you're fascinated by ancient mysteries, and subscribe, because the past is always being rewritten one genome at a time. See you next time. Stay curious.